All right, so we have these ones in here. We're just looking for the Q value of the cell. And this is written as a reaction. This is written as a reaction. If you look up here, these aren't written as a reaction. So I'm going to need to actually solve this one. So it's telling me the anode. So the anode would be the oxidation, and it would be the one that's giving up the electron. So that's correct. And then the cathode is the reduction. It's the one that is using electrons on the left. So that's correct. So I'm going to have to combine these together to actually solve this one. So that gives me, I need to multiply all of these times 3 and all of those times 2 because I've got to get my electron count up to 6 so that they can both cancel. So that gives me, I'm going to do the top section first. 3 zinc plus 6 OH, I'm going to leave some space for the next part of the reaction, goes to 3 ZnOH2 plus 6 electrons. Then if I go to the next one, that gives me 2 MnO4 plus 4 waters. I'm going to put on the side 4 waters plus my 6 electrons, so those are canceling. And then on my right-hand side, that is 2 MnO4 and 8 OH minus. Now I haven't put phases in, and that's actually super important, so I'm going to go back and add in my phases. This is a solid. The MnO4 is AQ. The OH is AQ. The water is a liquid. The zinc hydroxide is a solid. The MnO4 is AQ. Where's the MnO2? Did I write it weird? Oh, this is supposed to be MnO2. This one is a solid. And overall, because I have OH in both of them, 6 OH to 8 OH, I need my OH to cancel. So I'm getting rid of those OH, and I'm changing this one to a 2. I basically subtracted 6 from both sides, and that's how I got a 2 over there. So here's my ones that are going to be involved. That's AQ, solid, liquid, not using, solid, not using, solid, and this one is AQ. So those are the only 2 that are in phases that matter that I'll need to do this for. So Q is equal to OH squared over MnO4 squared. And then my OH right here, there's one OH in that. And so I can say that this is the same thing as being just the OH concentration. So that's 0.1 squared over, and then this one, MnO4, again, it's 1 to 1. That's the same thing as saying that this is the MnO4 concentration. So over 0.05 squared. Now I'll just plug it in. 0.1 squared divided by 0.05 squared. So the answer to that one is that the Q value is 4. We are going to be using the Q value in future lessons, so know that we've calculated that one. Now the next one was the Q value for this cell. Luckily, it's already in place. The only ones that are going to matter is my AQ and my AQ. So this is Cu plus 2 over Ag plus squared. And then this is the same thing as saying that's how much copper is in it. Because there's just one copper here, this is the same thing as saying that that's the molarity of just copper plus 2. And then for the Ag, this is the same thing as saying that that is also the molarity of just the Ag plus. So 0.02 over 0.02 squared. So that one's going to be 5. And sometimes these can be a wide range of numbers. They are not necessarily going to be these kinds of whole numbers. I just happen to have it working out that way. They can be numbers that range like 1 times 10 to the minus 5th, that kind of thing too. All right, so the last one, This one has the concentrations written in a different way. So yes, we have this. So that's great. So we know that the Q value is Cl minus squared over Zn 2 plus. So we know that, that's good. But then we have to go down here and look at what our values are. So this is the same thing as saying zinc plus 2. And then the chlorine, this is the concentration of the chlorine, so that's 1.5. But notice that I didn't actually include that, and I should have. Times my pressure of the chlorine gas. And then, so this is going to be chlorine, and then this is going to be Cl minus molarity. 0.1 squared over 0.119 times 1.51. There, minus 1. So there you go. That is the K value for this one.